Well, hello everyone, and welcome to the November 2023 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. There's no formal membership list, and we normally meet the second Thursday of every month except December when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. When we meet in person, you can join us for food and social at 6 p.m., and the meeting will start at 6:30 p.m. And when we were meeting in person, the location was the Object Computing Incorporated training room, and that's at 12,140 Woodcrest Executive Drive, Suite 310, and that, of course, is in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alspaugh, that's me in the middle, Wei-Chi Gao, and Kathy Zwang. You can reach all of us on the steering committee by sending an email to that email address at the bottom of your screen. That's javasigsc@ociweb.com. And I'd like to welcome our newest member of the steering committee, Robert Levitt. The St. Louis Java Users Group would not be possible without the support of our JUG sponsors. So from left to right, top to bottom, we have Object Computing Incorporated. They are our original founding sponsor going back to 1997, and they're still with us. So thank you very much to Object Computing Incorporated. And yes, we have been around since 1997. JFrog is a great sponsor. They've been sponsoring the Zoom meeting, which makes it possible to have our meetings here remotely. Signature Consultants and Adaptive Solutions Group are headhunters, and when we've been meeting in person, they would sponsor food every 3 months. So if you're looking for a Java position or a developer position generally, or you have a developer position to fill, just do a quick Google search on either one of them and let them know that you found out about them through the St. Louis Java Users Group. At the end of this meeting, we will be raffling 2 JetBrains licenses for any JetBrains desktop product of your choice. But if you're watching the recording, I do have to tell you, you do have to be present to win at the end of the meeting for the JetBrains licenses. Elastic has been sponsoring gift cards, and Intertech has been sponsoring the famous Screaming Flying Monkeys. What? Screaming Flying Monkeys? Oh, they're just little dolls, and if you throw them up against the wall, they scream, and they're a lot of fun. They are a training company, so if you're looking to improve your developer skills, just do a Google search for, I think it's intertech.com, and they've got lots of great training videos on lots of different developer skills there. At the end of the meeting, we will be raffling 2 Manning ebooks of your choice, and that will be, again, you have to be present to win on that one. So if you're watching the recording, I'm sorry you're too late there. Pearson will also sponsor physical books as well from time to time. So thank you to all of our JUG sponsors. As far as announcements go, I believe there might still be a few free 3-day JUG tickets available for the JCon World 2023 online conference. Now, that's an online conference November 20th through the 22nd. And if you want to get more information about that conference, you can go to that website there on your screen, 2023.world.jcon.1. Manning has recently given us a discount code too. So if you don't win the Manning raffle, you can get 40% off on any product by putting in that discount code when you place your order, JUG13. That's easy to remember. Again, JUG13. Now, as far as keeping up with upcoming presentations, the way to do that is real simple. Just go to our meetup group, meetup.com/gatewayjug, and that's where we update our presentation schedule. And if we ever do go back to in-person, we'll notify you there. If you are interested in giving a presentation or becoming a JUG sponsor, You can email the steering committee at that email address, the same one I gave you before. That's javasigsc@ociweb.com. So those are pretty much my announcements here, so I can hand things over here to our presenter. Tonight's presentation is titled, I Can Write the Code, but Getting Something Done is Another Matter, by Jessica Kerr, and she works at Honeycomb. So what I'm going to do is I'm going to click the Stop Sharing option, which will allow our presenter to share her screen, and take it away.
Jessica, you're muted.
Thank you. Somehow the button is completely hidden. All right, let's try that again.
I can hear you now. You sound great. Take it away.
Thanks, Bruce. And thanks, Ted, for emailing me and asking for this presentation. I'm Jessica Kerr, Jessitron online, jessitron.com. And I live in St. Louis. And I've come to the Jug many times over the last 20 years. It's been a long time. So thank you for continuing to run this. And over those last 20 years, I've written a lot of code, but I've also come to learn that as we progress in our careers, writing the code is definitely the easy part. And integrating the change that we want to make to the software into the world around the software and inside the software is much harder. For instance, there's a lot of things that bug me about the Honeycomb product. Well, no, there's a couple things that bug me about the Honeycomb product. I'm in developer relations, so I do a lot of demos. I show people how things work. I show new people around the product. And one thing that they do all the time is they've got this graph up and I'm like, oh, widen the time range. And they go looking for the time range. And what do they find? Well, they find this because it says 10 minutes and it's a drop down and they change it and something weird happens because that's not the drop down. No, actually, they need to scroll all the way up here above the query, sometimes off the screen, and change the time range here. And I'm like, oh, if only that drop down were grayed out, right? If we, wait, where is it? If we grayed out that drop down, unless they checked the box on the compare to, then they wouldn't be accidentally comparing when they meant to change the time range. And this would help new users in the product, which are the people that I care about. And one time, I had a donut pairing. So donut is like this app in Slack that you join a channel and it randomly pairs you up so that you get some sort of cross-pollination going on when you're remote. Right. So I had a donut meeting with Elliot, who's one of the engineers. And I was complaining about this. And he was like, oh, well, why don't we change it? And so we made that box gray out unless you check the button. And in an hour, the pull request was submitted. An hour. This was not a hard change. There it is, the pull request. Boom. And I left it to Elliot to get the pull request merged. And I was actually surprised when a couple days later, it was there. But a week after that, there's messages in Slack. And Dean, who works at Honeycomb, so he's a power user of the product, is complaining about, oh my God, when I want to compare, I have to click twice. And personally, I don't give a crap about a power user making an extra click compared to brand new users being able to find their way around the product at all. But other people do care, and other power users chimed in, and oh my gosh, we didn't socialize this change. And the designers are like, oh, we are surprised that this changed. Yeah, they do expect to know about all these things. And then they came up with something better, but no, there's accessibility concerns. Can you just back that out and we'll get it through the regular process? Sure, you will. So the PR was reverted. Yeah, So it went in on November 3rd, but it went out on November 28th of last year because one programmer or a pair, somebody to approve the pull request, isn't enough. That's not enough to make change in a system that's maintained by a few dozen people and used by thousands. Sad day. And did they actually get around to fixing it? Well, they did actually in August of this year. So 10 months later, we actually did get a fully designed and fancier change such that now there's no compared to Dropbox there. The actual time frame changer is in the right place, right above the graph, not way up high. And if you click it, one of the many options you get is compared to. It's actually much better, but it took a lot more than an hour. It took a whole team of people. There's product people, there's design people, there's an engineering manager and some engineers. Because software change is a social problem. I mean, beyond like what you can get working on your own computer. Programming is an intellectual problem. Software change is a social problem because a lot of people are affected. A lot of people need to know. A lot of people need to buy in. Oh, and it's so slow. But this is reality. And I mean, it's not a bad thing because the more a system is used, the more people are affected by it, the more significant a change is. It's frustrating to users for changes to like pop up and go away. The more useful your software is, the harder it is to change. So as the software you're working on gets more users, as it becomes more useful, the difference between coding and getting something done increases. And this talk is about the distance between these two. Coding here is represented by this little loop of road, and there are a lot of coding practices that are very important, and I'm not talking about those today. You can hear about those in a zillion million other presentations. I'm talking about the rest of this road. And when we think about our careers, we start out, we learn to code, and we think to advance in our career, we need to get better and better at coding. Yeah, no, it takes a lot more than that. You can get to senior developer by being good at coding and decent at collaboration. But for anything past that, you have to branch out. The ladder does not narrow as we go up, it broadens. It's more like climbing a tree, and you're going to find some branch of specialization, but you also need to know what's going on in the rest of the business. You need to work with design and product and everyone. Actual users, customer success. There's a branching out that we need to do to advance past the lower levels of senior developer. Now, I've got 3 stories about this today, about getting something done as opposed to just code. And these stories are all from Honeycomb. Now, Honeycomb is a fairly small company still. We're at like 160 people, maybe 50, 60 engineers. And also it's a great company. So I understand that at other companies, there's even more BS. So if it's this much work to get something done at Honeycomb, it's even more work to get it done in a larger company. Story number 2 is a much bigger project than the first one. You already heard the first story. The first story was the compared to dropdown. But this is the meaty one. This is the big one. The schema caching project is actually a big engineering project, but it's all outside the front end. It's all under the surface. So there's some background so you'll understand what this project does and why we needed it and why it was so much work, even though there are 0 customer impacting changes, other than maybe a little bit of a performance improvement. Honeycomb accepts data from our customers, and then we let them graph it and stuff. That data does not have a predefined schema. Instead, we build up the schema as the data arrives. So the schema is the description of the customer's data, all the attributes and stuff like that we've ever seen from them. And we're going to do some caching on that, because can we not hit the database so many times that when we have an outage, it's usually this database. Right, so there's some code involved. There's totally code involved in this. For instance, every time one of our services needs to fetch a database schema, first it looks in a local cache, and then it goes to the database. And of course, we're going to change this because the local cache isn't cutting it. So if it's not in the local cache, we're actually going to go to a shared cache. This project is about implementing a shared cache in Memcached. And if we can't find it there, then we can go to the big database. So there's definitely code changes, but that's not the story of the project. That's not the focus of the project. Go slide, go. There it goes. All right, all of these things happened, but what happened before that? Before we touched any code on this, well, first we had to decide what to do at all. Why would we do this project at all? And I like this because it very much starts with the business. This is a slide from our board deck, the deck that our executives present to the board members to tell them what we're planning to do in the future so that they can comment on it and give us advice. Now, obviously, I've changed the numbers. But that top line there is ARR, is annual recurring revenue. So these are our revenue projections for the coming, it was for 23, for this current year, because this story started in 2022. So we know how much revenue we want to get in 2023. And that means our software has to support that many customers. And our goal is smooth growth. So the platform team and the SRE team combined, they work together to make a plan for how are we going to take in that much revenue and the data associated with that much revenue smoothly. And they looked at all the places where our system was likely to fall over with the increased volume. And here's a very simple picture of Honeycomb, the system. Honeycomb is an observability tool. So we take in events from your software. This is called telemetry data. And we store it. And then developers and SREs and other people in the company who care can query that data and get clues about what's going on in the software, both when it's working and especially when it's not working. Okay, so events come in, value is received on the front end. Now, those events are what we charge by. So our revenue goals translates directly to a number of events. We know how many events we need to take in order to support that level of revenue. All right, looking at that number of events, and the value's on the other end. We know we need to make changes to Shepherd. Shepherd is the service, it's the name of a service that responds to incoming events, says, okay, I got this, throws them on a Kafka queue so they can get stored in the database. And so we're looking at scaling Shepherd ingest. And one of the observations in this report was that guaranteed problems, data set schema caching is too low a scaling limit. So we know we can't scale Shepherd enough because of data set schema caching. And that's how we know that we need to do this project. That's how it got started. Because we know as this event comes in, we have only so many Shepherds we can start up right now, because they all need to query the database about every record that comes in to find out what attributes we know about already and stuff like that. And they have their local caches, but their local caches are not cutting it. So we're going to make this shared cache. Shepherd dataset fetching. Yeah, the fetching of the schema was a major avalanche waiting to happen. In fact, earlier this year, we've had at least 2 major incidents and several little ones as a result of the database getting overloaded from too many schema fetches. Right. So we're going to need to change a bunch of code, but not just in one place. It's not just like one piece of code, because the thing about this schema is that it's pretty central to everything Honeycomb does. Of course, at ingest, we know we have scaling problems, but also the schema is fetched in a bunch of other places. The user interface needs to find it on the front end, and the database needs to know about it, and service map needs to know. Everything in our system needs to know about the schema, and it's all different code. So what we would like to do is like have one way to fetch the schemas from a shared cache so that we don't have every system having a different local cache. Well, they can also do that if they want. But there's one way, one correct way for them to retrieve the schema while minimizing the load on the central database. Oh, and we can find all these places. So this is actually a Honeycomb query that's useful for, where in our code do we currently access these database tables? And the query says where the SQL contains dataset columns. That's one of the key tables in the schema data. And we can find this db.callers, the function name. We can find a function and a service name for everywhere that's currently querying those in production. So it doesn't search the code, it searches the production telemetry data to say, hey, who's running SQL statements that hit this table? And we can find them all. So those are all places that we want to change as part of this project. Here's a bunch of services accessing the database. Our services, by the way, are all named after dogs. We tried to be a dog theme before we got onto the bee theme. Shepherd is one of these. But they're all accessing these database tables in a different way. And what we want is to like organize these queries so that we have a cohesive set of tables representing the schema, and they're all accessed through this caching layer. So we're trying to create a cohesive concept here. And behind every different service is a different team. Well, we have like 3 or 4 teams. It's not a ridiculous number. But there's different people involved on this. And so that means to support all this different functionality and to get the code changed in all these different places, we have to talk to people. Okay, it actually looks more like this because we're a remote company, so we'll talk to them on Zoom, that's fine. But there's a lot of talking to people to find out, okay, if we create this unified interface, what do we need to support? What are all the different functionalities necessary? And the performance levels, and how are we going to organize this? And talking to people about this ahead of time, it's getting them on board. This is a project that, yes, one team, the platform team, is doing most of the work and all of the planning, but everybody needs to care and everybody needs to hear about it. And here's one of the meetings describing what we're happening as the platform team. This is Nicole, and they're helping present what's happening to the other teams.
The word schema has had a lot of different definitions, I think, at Honeycomb, depending on which part of the code base you're in. For us and this project and going forward, we have defined schema to mean anything that has the event columns, the derived columns, and any definitions associated with either a data set or an environment.
So everybody really had a different way of even thinking what a schema was, because every service accessed different subsets of that table. So Nicole and team had to get people on the same page about what we're even talking about when we say schema caching, because these words don't have a single definition. What is a data set? What is the schema? These words were used differently in different places all over. So reaching unity around that was a major part of this project that happened. I think this actually happened in parallel with coding. Come on. So they created not just a new service, but a bounded context where where the word schema and the word data set mean a very specific thing. And then even if these services also use these words in other ways, when we're talking about retrieving the schema from the schema cache, people know what we're talking about. And that is really useful because it helps people understand the software. And I like to think of the production software, these boxes and cylinders represent production software here. I like to think of production software as part of the team, along with the people and along with all the tools that we use, the code base, the IDE, the CI/CD, the automated tests, and our observability, all the tools that we use to communicate to the code and to get it to talk to us. That's the observability. All of this is how we work together as a team with the production code. And when we work like this in a way that considers all the stakeholders, all the people who are impacted by our changes, then we're broadening and we're thinking about more than just our team and the software we're responsible for. We're thinking about the wider software system. That's a big part of what makes the difference between a mid-level senior and then staff engineer, is how broadly are you thinking about the system. So the schema caching, the team working on schema caching thought about Honeycomb as a whole very broadly and made the necessary social connections and drew other people in early. So yeah, the code writing is just a piece of this. The people are part of the system. It's a socio-technical system. And the people are part of it. And we need to pull the people in if we're going to change the code. So we did that in Zoom. And that's a bunch of stuff that came before the coding. And then, yeah, there's, unit tests and code reviews and linting and all that stuff, integration tests. But then after the pull request is merged, there's a lot that goes on. As an observability company, it's easy for us to say, the first thing we do is incorporate telemetry emission into the code. So we're sure we instrument our code using open telemetry. That's the modern standard for emitting observability data, and it's all open source. So we include that in the code to begin with so that we can see what's happening. We can see what's happening locally, and we can see what's happening in production. And that looks like this. Here's a trace of, this is actually the schema cache updater. So the schema cache updater describes itself. It describes what it does every time it runs. It does some get batches, and then it uploads to memcache. And now that data actually gets emitted. Okay, this is confusing, but it's necessary to understand the next video, which is my favorite part. Honeycomb is an observability product. And so our customers send us data, we store it, we show them users, or we show them graphs and traces and stuff in the UI. But our product, our services, Shepherd and all the other dogs, as they're running, they're emitting telemetry data that we need to observe. And we don't send that right back into our product, because then if our product went down, we wouldn't be able to see what was going on. That would be bad. So we send it to another instance of Honeycomb, which is called dog food, because it's like we're eating our own dog food by using our product on our product. We use Honeycomb to debug Honeycomb. So our production telemetry goes to dog food. And dog food is also a place where we turn on features early so that the whole company internally can experiment with them. And so dog food has its own telemetry emission, and that has to go somewhere. And we send it to a third instance of Honeycomb called Kibble. So in this next video, Ben is going to talk about some progress on the schema caching project, and he's actually showing Kibble. He has Kibble open to look at what's going on in dog food.
What we're looking at here is Shepherd, our API server, just running in its steady state in dog food, accepting traffic. And every time it accepts an event in the front door, it needs to do a bunch of validation, including checking out to see if there are any new columns or things like that. So it has a local cache, it hits that local cache, but these caches expire, it falls through to the database. This orange line here is the steady state of Shepherd just in its regular operation saying, hey, you know what, my cache is old, let me go out to the database and get a fresh copy just to make sure everything's cool and up to date. So feature flag flipped here And we have a visualization of it hitting the local cache that was happening before, just wasn't visualized, 8,000 times per second. So that's load that's already not hitting the database. But this blue thing here, this is new. Instead of going out to the database to ask for an up-to-date copy, the Shepherd is reaching out to a shared Memcache instance in AWS to get a mostly up-to-date copy. And that's fine, that's good enough for Shepherd. And every spot on that blue line is a database call that is avoided. You can see there are a couple of database calls that still need to happen, and that's fine. Those are falling through to the database. Like I said, fine. So there are two things that it's really cool about this. First, that entire line of orange database traffic is just gone. And for steady state traffic, I love seeing traffic disappear. When we restart services like Shepherd, like Bassett, it generates an abnormally high load as there is no cache, and it goes out and fills the whole thing. So I'm hoping here, dog food deploy has happened recently. Let me just add a heat map on uptime to confirm. We should see little trails from all of the restarting Shepherds. And yeah, all of that is hitting the remote cache. This came up in an incident yesterday and again this morning about database load. So I am super pumped to see this. It's only in dog food, not production yet, but so close and live and working in our system.
Thanks, Ben. So that was a rollout of some schema caching code, not to production, but to dog food. Now the same code runs in dog food and production, but we have it behind feature flags. This is an example of a feature flag, use schema service, so that while we have the same code in all of our environments, the feature flags are different. And so we're only using this new schema cache in dog food in this case. And now what feature flags, super important, separate your code delivery from when the feature starts working, which is, I mean, marketing and product have some say in when the feature starts working, but we need to keep our code consistent with very frequent deployments. That does mean a little extra code. You do have to check the feature flag before executing the new stuff. And this is an example of a feature flag. We're graphing the feature flag. How many services are using schema caching? Oh, I should run this again because I think there'll be even more using it now than there were in July. And also we emit telemetry so that we can see what's happening. So here's a trace in Shepherd and no, actually this isn't Poodle, but anyway, here's a trace that's using the schema cache with get datasets and schemas for request. Oh, but what's this? What's this span saying that we also did get old data sets and schemas, schema columns, whatever, something for the request? What's happening here is a shadow deployment. So there's some parts of our system that are super crucial. In particular, whenever a customer runs a query, the front end, well, the back end service that the front end is talking to, it's called Poodle because everything's a dog and the Poodle is the fancy dog that is the front end. Okay, so Poodle is translating the query that the user entered into something our database can understand. This is a custom database. It's not a friendly language. It's turning the dataset names into dataset IDs and the columns into IDs and the derived columns into formulas and all this stuff. And it does that based on the schema. And it is very important that we don't screw that up. So moving to the schema cache changed this code significantly. And we needed to make sure that changing that code had no effect on our customers. So for any given query, the query spec that's going to the database should be the same before and after the schema caching change. So what we're doing is we're noticing there's an example of a query spec, charming, isn't it? But we're able to look at it. And so what we're doing is in the code, we're not just running the old one or the new one, But if the feature flag says to use the new one, we also use the old one. And then we compare those and then use the old one. So in this case, the schema caching has not been rolled out to production as a customer facing thing, but it is being executed in production because we couldn't possibly test every query and every schema. There's just so many combinations, but what we can test is all the ones that people are actually using. So we love testing in production in Honeycomb. We don't only test in production, but we do let our customers run stuff, and then we look at the results. So this shadow deploy is running both and then comparing them. And then we add some telemetry code around this so that we see what happened in the old one, what happened in the new one, and what's the difference. And we're comparing those query specs before and after. Yes, down here we get to the client compare, retriever client compare span, and that is where we have both the old and the new query spec. And they're very long. We did wind up having to limit it to 10,000 characters, I think. And we had wound up having to do things like, oops, these show up as different, but they're actually the same because the column order is different. And so alphabetize them or numerically order them so that we get a uniform output for each semantic query spec. But we are able to compare those and say, how often are they different? And here's a graph. There was still, this is the graph of whether they match. There's a lot of trues, a lot of, yeah, they're the same, they're the same, they're the same. One false, still a tiny bit of work to do. But this started out, this graph looked different. A lot of them were false. Well, I don't know, a handful, more than one. And then some of that was just reorder the query spec, so it's more comparable. But there were bugs, they did find bugs in the new schema caching code where they'd misunderstood how something was used, and we needed to bring it back into consistency with the existing behavior. And sometimes the existing behavior was actually wrong, so bugs were found there too. And then you got the question of, oh my gosh, do we duplicate the bug in the new code? I have seen that in production more than once, but in this case, fortunately, we were able to actually fix the bug, and that was a better result. But it's taken months to make sure they were all the same and gain confidence that we've gotten all of them. Oh, and then we also compare performance. Which one is faster when you're running both? You can check. So the orange line here is the new schema caching code, and the purple line is the old. So that bottom graph there is the median, and the old code has a higher median, so it's taking longer on average than the new code. So that's good. That's an improvement. At the P95, the outliers about the same. So we can check that as well. Now, this kind of shadow deploy is really powerful because it gave us a lot of confidence that we weren't breaking anything in some very sensitive mission critical code. Now, you can't always do this. One, it's a lot of work. So only do it where it's really critical. And in this case, we were not like CPU bound, so we weren't taking a performance hit by doing both at the same time. And sometimes you don't have output that can be compared. In other places, we weren't able to compare the results exactly, but we could do sanity checks like, oh, are they the same length? Is one empty and the other not? Little stuff. So this shadow deploy is like a very serious responsibility, and it continues, but we really only did this in a couple places. Most places we changed it, we tested it, we declared it good, we put it in production, and then we kept looking at it. So currently the schema cache is used by some services and some not. Poodle was doing the shadow deploy. I'm pretty sure now, that was in July, and now it's November. I think Poodle has moved past that and is now using the new schema cache. And then you got to go back, you take out the feature flag code and you take out the shadow deploy code. And that's fine. This is part of the process, because getting something into production is not one shot and it's over. There's getting it into the different environments and behind feature flags. And then there's removing the feature flags. And yeah, these shadow deployments add layers and time. They add time, but this is like a responsible change. So when is it done? I mean, software is never done until it's out of production. And it's okay that not all of our code uses the new schema cache yet. It's gradually moving and new requirements come up. There's one of the services tried to switch over, but then there wasn't a batch mode in the schema caching. So it was too slow, retrieving 1,000 data sets one at a time. So the code has to evolve together. The schema caching service has to evolve along with the code that's changing in order to use it. It's all a process. I mean, every target architecture is just a direction, right? And you'll have a new target architecture long before you reach any one of them. If you actually reach your target architecture, you're spending too much time on that, and you should like go add some features or in other way complicate your life in a way that's good for the business. Right. So all of this stuff takes place after the coding, and this stuff is in production, but users haven't even seen it yet. It's quite a process. And the schema caching project, the analysis behind it was done in August of last year. It's still, I mean, it's still ongoing to some degree, but it's nobody's focus anymore. It's stable and it's in production and it's helping. So that's good. But it was a long work. Our job as developers is more than writing code. We have to design change. We have to say, not only what change am I going to make, but how am I going to integrate that change into all the rest of the system, the socio-technical system, the people, and the other software that are affected. Sometimes those people are just internal. Sometimes they're also our users. And for a very clear and much shorter example of designing change, here is the third story, and it's a happier story, the nav bar reorder. This was done by the green team. The green team is charged with growth at Honeycomb. So their job is to help people get value from, like initial value from the tool, especially to get them from making an account to sending events to getting their first clue. So they studied using Amplitude, is the tool that we use to follow people's paths as they click around in the product. They studied what new users did when they got into the Honeycomb interface, and they found they often wound up on this page, this settings page. Add a description, default granularity. No, this is like advanced stuff that like your SRE team probably wants to configure about your data, but this is not where you want to be as a new user. So they're like, how can we get people to go run a query instead? We want them to run a query. They looked at the navigation bar, and this page was accessed by clicking on data sets, which, I mean, in a SQL database or something, I would like click on a database in order to write a query. So people thought you needed to go from a data set to a query, but no, you're supposed to click on that new query button right above it. Okay, so they came up with this idea. The product people and the whole team really came up with this idea of reordering the navigation bar. They took the word new out of new query because that's intimidating and made it really clear. Query is here. We moved data sets way down to the bottom and changed it to data settings, which is way more accurate. And then let's see, service map is up, history's down. Like, where do new people need to go? Now, this nav bar is it's hot real estate, right? One, people use it all the time. They have muscle memory. You don't want to change it often. Two, every item on this navigation bar is owned by a team, and the team that owns history doesn't want to be at the bottom. So how do you get buy-in from the history team that their stuff's moving down? Well, this is what they did. It's easy enough for them to run an experiment. Nobody objects to an experiment. I mean, one of our values at Honeycomb is everything is an experiment. So nobody complains about that. So made a feature flag. The code change for this is an hour of code, maybe. This is a very small code change. But they put it behind a feature flag. And then they set the feature flag to be active for 50% of new free teams. So anybody can create a free account at Honeycomb. You can send us 20 million events a month, which will totally get you some really useful observability on a small system or a large system in a test environment, or any system in local. Yeah, so we have a lot of free teams, and as they come in, they've never seen the old nav bar. So let's give them the new nav bar. The other thing about free teams that's really nice is that they don't have an account manager. They don't have a customer success person or anybody who's going to complain about somebody messing with their nav bar. While we always love experiments, we don't experiment with our enterprise customers. Well, I mean, we like negotiate and talk to them first. We don't just change things. But free teams are fair game. So we ran this for about a month, I think, maybe 3 weeks. And then our product people went back and looked at the data and found that before the change, like 79 teams went to data settings, and afterward 4 did. So people are not getting lost in that settings screen where they really don't need to be. And more people clicked on good things like queries and stuff. And then we asked, did more people run a query? Because that's our real goal. And yeah, I mean, a little bit, but its sample size is small enough that it's not statistically significant, but it definitely didn't hurt. It's not like this plummeted. And so when you go and you talk to the people and you've got data that says, look how much better this is. Look how people are succeeding with this new nav bar. Then the history team is like, oh, well, can't argue with that. Guess I'm going to the bottom. And so this like gathering data made it really easy to socialize the change, and everybody was naturally on board. So a lot of planning went into that, the feature flagging and the experiments and the studying of what people do before and after, and the measuring of what people are doing. That's a big undertaking that wasn't part of this project, but was really useful here. So this project succeeded very well. And it was even fast. I mean, April to June, that's only 2 months. That's pretty quick to get a change of this magnitude out in production. Well, I mean, it's an easy code change, right? But it had a significant effect on the user experience. So it was a big change in its usefulness, even while being a tiny change in the code. And that's what I want. I mean, as a software developer, my goal is not to write code, because the more code I write, the more code somebody's got to maintain, and that is not a win. My goal is to provide value to customers. And if I can do that with small changes like this, win. So it took a lot of steps and a lot of conditions that the team set up. That was a win. I like the navbar reorder. Okay, PowerPoint, you can do it. They did some strong designing of change right there. So yeah, beyond your own computer, software change is a social problem. And sometimes this makes me sad because it's just so much work to get anything done. And I see a problem and I want to just go fix it. And I know that will be months of chasing down a pull request and socializing it. And a code is so easy. But there's one time that we get to have fun. 1 week out of the year at Honeycomb is Hack Week, and all the engineers work on a project of their choice. We form teams. We like, hey, I want to change how we alert on SLOs. Who's in? And other people will join in. We give little pitches, right? And then we work for 3 days on that project, and then on Friday, at demo day, we present what we did, and that's a lot of fun. So this year in June, these were the Hack Week projects. They were pretty exciting, and just big changes to the product are at least tried out here, and then somebody wins. Schema Cache was actually helpful in this because it helped It helped some teams implement their stuff faster because they had that solid concept to build on. But also, somebody wins a prize for the voted on favorite. But more importantly, at least one of these was so well implemented in 3.5 days that product team couldn't not put it on the roadmap. The burn rate alerts team had a designer, it had an engineer or two, and it had a docs person. And they implemented this so well with like very carefully designed UI and completely integrated into the product. And all the documentation was written that the product leadership was like, we can't not put it on the roadmap. So that actually finally dropped into production today. And I'm very happy about it. And there's still some work to do. No, there's still a pull request in to add it to the API. So that'll be next week. But I'm very excited to use these burn rate alerts in my chaos engineering webinar on Monday. So yeah, that was one that people have been asking for years, both internally and externally, and they did it on Hack Week. And then it was like, oh, okay, I guess this isn't too hard. Hack Week for the win. Yeah, and this is another opportunity for growth. As we think about our career, do we want to just go up the ladder and get better at coding, or do we want to branch out? And if you want to branch out, or trust me, if you want to get past senior and have more influence on the world, then here are some necessary bits. You need to know how your code fits the business. And you can do this at any level as a developer if you ask enough questions. Sometimes you got to find the right people and get to know them, to ask the questions to find out what value your code is adding. Because when you know that, you can do it better, and also you can get it integrated more smoothly. So understand the value stream between the customer and you, and where you're working. And then add telemetry to your code so that when it has value, you can prove it. You can graph it and say, look, people used this feature this many times. They hit the screen and then they succeeded at this thing. This is one thing I love about observability. I mean, I'm a developer, not an SRE. I'm not usually involved with incidents. That's not my first priority, but I do really care whether the code I wrote is being used and being used in the way that I thought they were going to use it. So I get that out of looking at my data in Honeycomb, the data about my code. And then code for change, and code for change by a future team, not like yourself. It's not going to be you, or if it is you, you won't remember it that well. But comments and naming and all those useful coding practices, but also that telemetry. Again, if you get the code to tell its story in a trace, yeah, there's a trace. If you get the code to tell the story of what it's doing, then it's a lot easier for a person to find the code to change and to know that they changed it correctly. That's the other part of observability that I really love. It teaches me how the system works when it's working. And finally, expect to design change. Expect to spend most of your time working on migrations and mitigations and defining and meeting milestones. There's not done, but there is the next milestone we're in this service, we're in dog food, we're in production behind a feature flag, and so on. And finally, part of integrating into a system, into the system that you're trying to change, is marketing. So at a simplest level, there's a change log that went in for the navigation or the nav bar reorder. But the burn rate alerts took a lot of documentation. And the changes that we recently put in place for Kubernetes, this is our latest big launch, is for people to use them, they have to know that they exist. And so there's a whole marketing effort, including our team and DevRel, and a lot of documentation work to make it possible for people to use this. And even internally, though, the schema caching team did a lot of internal marketing. They really sold it to people internally, presenting at demo day and holding whole meetings about it and asking people individually and meeting with each team that has code that's affected. So some of that marketing is entirely internal. But if the people don't know about it, it might as well not exist, your new feature. Value is an emergent property. It takes all of this. It takes the documentation. It takes all the integrations. It takes all the other software that's integrating with you. It takes the browsers working right. And it takes legal, keeping your software safe, and the security team also. And all of these people contribute to the value that we give to our customers. You like to think, well, there wouldn't be any value if I weren't coding it. True. There also wouldn't be any value if no one was out marketing, and if salespeople weren't out helping the people who want to buy our product to navigate their internal organization so that they can buy our product. I'm glad I don't have that job. But it takes all of this to give value to people. And when we appreciate that, then we don't mind contributing to those other parts of the system and considering them. So in my career progression, I've moved from programming, from does it run, to systems. Is it useful? Does it even matter in the world? That's what I care about. And I don't just try to get better at what I do. I try to get better at having impact and looking wider. And that means I think about wider time frames. I remember my first programming job, this was like my college internship. What I loved about it was that I could leave at 5 p.m. and I had no homework. I just thought that was great. And I was like, yeah, I want to do this after college. Which is true. But, you know, after I got like a real job and a real team, then I cared about the whole project. And then as I matured as a software developer, and I started caring about like readable code and patterns and languages. And I'm thinking like about my code being changeable in the future. And then like as a person, eventually we get to caring about whether the company succeeds. And then the people around us, you know, how is my work affecting the people on my team and my wider company and the people that our product serves? Am I making my customers' lives better? Am I raising their expectations of how software should interact with people? And I back in my 20s, I wanted to leave at 5 p.m. and just go party or whatever. And now my liver's done with that. And so I actually find it much more fulfilling to think in a much broader way about the systems that we're building together. And I think about more than just my team, my whole team, but also all the surrounding teams and and the people that I can't even see, which are our customers using the product and the other software that they use that this is going to interact and be compatible with. It's systems all the way up. If you want to get better at the wider system, if you want to branch out, both literally and figuratively, I feel like I should recommend you some books or so. These are some of the ones that have influenced me positively in this branching out. And these are all linked in the page of linky things that's at the end of the presentation. But there's a better idea, which is talk to the other people in your organization. Talk to people who are, if you're in development, talk to people in infrastructure, talk to people in leadership, talk to people in legal and security and sales. Sales is actually a really good one. Oh, and customer support, they know so much. Talk to these people. And especially with your leadership, ask what books they're reading. Because if you read the books that they like, then you'll have a common basis for communication. And that shared language, again, that is really powerful for understanding how your code fits into the business and for being able to communicate why we should have this new tool or why we should make this change and what is the business customer reason for it. So yeah, make friends in the broader organization and ask them what books they like. It's a great conversation question. It makes people feel good to answer it. That's the story. You can find more at this link. You can find like all the recommendations and some related presentations, and also a suggestion to subscribe to our newsletter about open telemetry if you're into instrumenting your code. And yeah, I'm Jessitron. Thanks. Do we have any questions? Ooh, I see a long one. Goody. Okay, now I can look at the chat. And Paul says people are such a pain. Indeed. And they're all like different pains too, unlike code. Bruce says, once you have a new feature in production for a while and you're confident it works and the old code is no longer needed, do you at some point go back and remove the feature flag? Yes. Now, when I was writing this presentation, I asked Elliot, who's on the green team, so did anybody remove the code for the feature flag for the navbar reorder? And he was like, actually, they reorged our team. And I don't think so. But I should go check it today. I bet it's out today. So yes, you totally go back and remove the feature flag. And the old code and the test for the old code, definitely. How do you test that the cleanup process itself doesn't introduce bugs? The same way you test everything. And how do you determine when the old code is no longer needed? Oh, okay. So that's how do you determine when the old code is no longer needed? When the feature flag is on in all the environments and it's been that way for a month, you can be pretty sure you're not rolling it back. Often by that time, it would be really hard to roll it back. But you do want to make sure it's stable in production for sometimes it's a week, sometimes it's a month. And do make sure that there's a card on your board wherever you track your tasks for removing that old code. Is this considered cleaning up technical debt because unused feature flags complicate the code base? Yes. When that stuff escapes, it is totally technical debt because it is making the code harder to read. Yeah. I mean, feature flags do make the code harder to read because which one of these things is it doing? And the answer is it could be either, and you'll have to look at the feature flags. Oh, and another thing that we get wrong with those is people will turn the feature flag on in dog food and then production, but it never gets turned on in our local development environments. This has burned me a couple times. And so your local development environment starts diverging from production. I kind of feel like we should turn them on in local development really early. Like, I mean, people turn them on in their own local development, but you need to commit a change to the file that is everybody's local development. So yeah, those old feature flags are totally technical debt. But what they get you is the ability to deploy without approval from anybody in marketing or product because your deploys are invisible to people looking at the UI. And that is essential to being able to keep your deploy process quick, keep your the what do you call it? The time from commit to production, your lead time, keep your lead time low, and be able to test stuff in multiple environments and also keep the code base consistent throughout. We never, ever, ever deploy a branch. Only main. No hot fixes. Well, I mean, you hot fix it on main. You don't hot fix it separately. But that's because main is always in a deployable state because of feature flags. More questions. I'm going to hit stop share. So there.
Okay, well, thanks for a great presentation here. I was just going to throw in one. So in this process, have you come across any particular tools and techniques that help to facilitate the social process of getting your ideas here into production? Is anything that you might find is a particular like social lubricant and facilitates the collaboration process?
That's a good question. Donut pairings help because I do get to know engineers across the organization.
Okay.
Demo day is a tradition that we have in Honeycomb that's really powerful. And I would recommend it. In a big company, you do it at an org level, not the company level, but every Friday, a bunch of people present like 5 minutes each. Here's this thing we changed. Look, it's different, but they always include why it matters. Like you saw Ben in demo day with the schema caching, and he totally talked about why it mattered. And every change includes that. And that socializes a lot. Simple things like code owners files in GitHub help. Who is currently responsible for this code? So you know who to ask. If you see you need to change it. And then, I mean, everything that is a social lubricant, which is like talking to people. If you have a shared kitchen, go ask people what they know about. Go ask people what books they read randomly.
Okay.
And then if you're remote, we have a lot of shared channels in Slack that are like, Misk, so fuzzy, pet pictures, Misk, fancy house things. Tell me about your bathroom remodel. Those, like, they're not work related, and yet they are human related. And to work together well, we need to be humans together. And little stuff like that goes a long way. It just, especially since COVID, I have come to desperately appreciate small talk.
Okay.
I just take that opportunity when I have it, because I'm like, let us acknowledge that we are each human. In Zoom meetings, always let people in before the meeting starts, like so that we can kind of trickle in, and the people who are there early can chit chat. Another thing that we do is start meetings 5 minutes late. Some people will actually get there on the hour, and then they can chit chat until 5 minutes in, and by then everyone's expected to be there, having finished and closed off whatever call was running over before that. It's those little places to talk to people that make all of this easier.
Okay. I think Ted had a question here in the chat. How do you find people internally to test the changes, playing the role of new users to the system?
Nice. Now in Honeycomb, it's easy because it's a product for software developers. So you put a change in dog food, they're using it. Mm-hmm. Because we are constantly using our product, that makes it easy. But we also have bug bashes. So when a team has a release like the new EU instance, we just stood up an instance of Honeycomb in the EU for the first time, and they had a bug bash. And this was like, there's an hour set aside, and there's a Zoom that you can join if you want, but also here's a document of things we would like people to test. And they were like, just use this instance as with your normal flow or whatever you can think of. And then whoever finds the most bugs gets a prize, or the top 3 or something like that.
Okay.
And then when you find a bug, here's a place in Asana to put it, stuff like that. So that's kind of fun.
Okay. All right. Does anybody else have any questions to put in the chat that they'd like to ask our speaker? Okay, I'm not seeing anything. So normally if we're in person, we'd have a big round of applause to thank you for a great presentation. So what I'm going to do here is I'm going to end the recording, and then we'll see if we can move to the raffle here.